All right, so 6.3 questions. These problems say to graph over a 2-period interval, but we're just going to graph the, positive x-axis side, okay? When we get to shifting ones, we'll do the same thing, but sometimes because of a shift, it may cause it to shift into the negative x-axis just a little bit, and so we'll have to adjust for that, but I'm going to modify the instructions a little bit. Graph 1 period of the function state amplitude period the scale and reflected if applicable. So this is my modified instructions for problems 23 through 40 on page 601. All right, so 24. Y equals the sine of 2/3 x. So following my steps that we had up here, okay, first I'm going to state the amplitude. So the amplitude is equal to, so I'm looking for the number that's in front of sine. So what number is in front of sine? Huh?
Y.
Number.
Oh, number?
In front of sine.
Oh, 2/3.
In front. Over here. Right here.
Nothing.
1.
That would-
Then the period is 2 pi over b. What is b? It's the number that's after sine. You don't need your unit circle for this. 2 over 3. Okay, so notice I have 2 pi over 2/3, okay? So I have a fraction and a fraction. So how do I need to get that so it's not like that? Keep, change, flip. So this is going to be 2 pi times 3 over 2.
Just be 3 pi or pi.
Yeah. 2's cancel, so we're left with 3 pi, so that's the period. For the scale, we do 3 pi, so the period, over 4. So that means increments of 3 pi over 4 are going to be what I need to get 1 full cycle on the graph. And then is this graph reflected? Because that's the only other thing I can deal with this one. So is there a negative out front? No, so it's not reflected, so I don't need to do anything with that on this one. So I'm going to set up my graph. So again, I'm only going to do the one side because that's all I really care about.
Wait, how'd you do scale again?
It's the period divided by 4.
Oh.
So it was 3 pi over 4. So you're always going to have 4 tick marks, okay, to complete one full thing. Okay, so 0 is the first one, so I guess it's 5, but 0 is your first one, and then we're going to count increments. So you're going to have 4 dash marks that you write. So increments of 3 pi over 4. So this is 3 pi over 4 here. I need to add 3 pi over 4, so that's going to be 6 pi over 4. which if it reduces, you should reduce it. So 6 pi over 4 would be 3 pi over 2. Then add another 3 pi over 4, so that would be 9 pi over 4. And then add another 3 pi over 4, so 9 pi over 4. 3 pi over 4 would be 12 pi over 4, which reduces to 3 pi. So whatever your period is, you always will know that your last mark has to be that number. If it's not, then something's wrong. Now I've got an amplitude of 1, so I'm going to set up -1 to 1 here. And where did we say sine always starts?
0.
At 0. So put a point here, and the next thing that it does is it goes up. Okay, so if we go back to our parent function for sine, we started at 0, we went up, come down, like that. So we go up, down, down, up. Okay, this is why I said it's not necessarily going to work using your unit circle, because some of those values, like the sine of 3 pi over 4 is not 1, right? So just looking at the unit circle isn't always going to help you. For the parent function, it will. For the other ones, there's more math that you would have to do to actually get to that. So that's why it doesn't work. So you just need to like learn the pattern for the way that the graph goes. So thumbs up, down, and you officially graphed your first trig function. That's not a parent function. Let's see. Let's do cosine 1. 28. Y equals the cosine of 2x. So what's the first thing that I do?
Find 2x.
What? Step 1.
Oh. So it'd be 1.
Okay, state the
one.
amplitude. So the number in front of cosine is 1. So the amplitude is equal to 1. What's next? Find the what? What's step 2? Yes.
Period.
So the period is, what's the formula?
2 pi over 2.
Okay, so 2 pi over b. B is 2 in this case, so 2 pi over 2, which reduces to pi. Then what's step 3?
Scale.
How do I do that?
Pi over 4.
Pi over 4, so the period divided by 4. And it, is this reflected?
No.
No, it's not negative. So I can set up my graph for this one. So since I know it's going all the way out to pi, if you want to put that mark on there first, because you know you've got to end up there. And then I have 3 other ones that I need to find. So the first one is going to be pi over 4. So what is the next one?
Pi over, no.
You can also do it by cutting whatever the period is in half, and that will give you the middle one. So what's half of pi?
Half a pi. Half a pi.
Yeah, pi over 2.
Oh, okay.
And then what would this one be? This is 1 pi over 4. This is 2 pi over 4. So this would be
3 pi over 6. 3 pi over 9. 3 pi over 4.
3 pi over 4. And then this one was 4 pi over 4, which reduced to pi. So, where does cosine always start?
1.
At 1, so that's up here. So I should put a 1 and -1 on here. And then it goes down, so to 0, to -1, back to 0, up to 1. And notice that on the ends, I turn it and have it going back down, okay, because that's the next thing that it's going to do when the graph continues, okay? So putting those arrows on it shows that it's continuing, so I'm showing that it's continuing in the, like, downward direction on that. Let's see. $30. Y equals 3 sine 2x. So what's my first step for this one?
Find the amplitude. That's 3.
The amplitude is 3.
Find the period, which is 2 pi over 2.
2 pi over 2, which reduces to pi. Then what?
And you find the scale, which is pi over 4.
Yep, pi over 4.
So it's like the same one.
Yeah, so this one's going to be, the x scaling is going to be the same, but the amplitude is different on this one. So when I do the...
It's up to 3 and down 3.
Yep, so when I do the graph, now I typically will still just put one little tick mark on each one, but I'm going to label that this is 3 and -3, okay? So that way I show that I at least recognize that. But most people don't go on and put all the little tick marks on there until we get to the ones where they're shifting up and down and stuff like that, because then you obviously need other numbers on there. But, so the scaling is going to be the same way, so I'm out to pi. Half of that is pi over 2, and then the scale, so pi over 4, and 3 pi over 4. So then sine starts where?
0.
0. So sine starts here, then it goes up. So notice it's all the way up at that 3 mark, then down to 0, down to -3, and then back to 0. So then connect them. All right, 32. This will probably be our last one for today. Y equals -5 cosine of 2x.
Amplitude is 5. Period is 2 pi over 2.
Yep, so I just want to point one thing out really fast. You're right, but the amplitude is the absolute value of -5. So you are exactly right with what you said of it being 5, but I just want to show that that's where the absolute value part comes in handy. Okay? Some people just disregard the negative and they just say amplitude is 5, which I'm guessing is what you did. But that's why we have the absolute value when we look at that, because the amplitude has to be the distance from 0. So, anyways. Okay, you said the period was what?
2 pi over 2.
2 pi over 2, which is pi. Scale for this one. pi over 4. And because of that negative sign, what's happening to this one?
Oh, it's reflected.
Okay, so I'm going to make a note that this has been reflected. Now, I'm going to graph this as if it's not reflected first. Okay, and so I'm going to, on this graph, I'm going to have two graphs. So I'm going to show you what that looks like so you can actually see the reflected graph. Okay, so when we get to the stuff tomorrow with where we're shifting the graph around, you're going to end up potentially having like 3 or 4 graphs on your one singular graph. So you might want to have a couple different colors to do that with. Okay, or you can use some of mine. But all right, so set up. Whoa, I made that really big. So set up same way. So I'm at the amplitude of 5 and negative 5 there. Period, the same one I've been doing, so same number. So pi over 2, pi over 4, 3 pi over 4. All right, so I'm going to graph this, assuming it's not reflected first, okay? So where does cosine start?
The 1.
Okay, so yes, normally at 1, but in this case it's 5 because that's our amplitude. And then it goes down, so down to 0, down to negative 5, back up to 0, up to 5. Okay, so this is the graph not reflected. Okay, so normally I'll come put a little like squiggly line to show what color I'm graphing each step in. So now in pink, I'm going to show the graph that's been reflected. Okay, so for it to be reflected, every point is flipping over the x-axis. Okay, so this point that starts here at 5 is actually going to be down here at negative 5. Okay, the point at 0, well, that can't flip over, right? It's just going to stay 0. So that one stays on the 0. This point that's down here at negative 5 needs to flip over the x-axis, so it's going up here to 5. The point at 0 is going to stay. The point up here at 5 is going to flip down here to negative 5. And so my reflected graph is this one. So this one, the way I'll specify it is that I'll put a little arrow showing that that's my final graph, that everything has been done to it. Okay. Once you get more familiar with these graphs and more comfortable with them, you can actually do reflections right from the beginning. Okay. Translations and stuff, I would say we're going to do step by step. Okay. In pre-cal, I'll show you like what I did with them is I showed them how to do step by step. Some of them chose to do that. Some of them chose to do all the reflections and shifts and all that in one step. And that gets a little risky. Okay. So we're going to stop there for today because these are like the basic ones. I'm going to give you one of each kind that you need to do tonight. Okay. And then tomorrow we'll add on the shifting. Okay. So problems from 6.3, I want you to do number 27 and 31. Okay, so one of those is going to be reflected and one is not, so you get some practice with that. But I want you to do those so you can make sure you have the general starting point before we add on the next step of them getting a little bit more difficult. So.